Hello, welcome to a quick demo on shadows in my game engine. These shadows are generated using the shadow mapping technique with cascaded shadow maps to cover large areas. To generate one of these shadow maps, the scene is rendered from the light's perspective, in this case the sun, with only the depth information recorded. The full scene is then rendered and this map is used to calculate which parts of the screen should be in shadow. I put together some towers to demonstrate how the nearby shadows and distant shadows are handled. The general idea is that nearby shadows will use a more detailed map, while the further away shadows will use a broader, less detailed map. This is accomplished with cascaded shadow mapping, which means that each chunk of the screen gets its own shadow map depending on the distance from the viewer. I'll include an image illustrating this technique on the screen. You can see that even the distant towers are casting shadows. These shadows will be lower quality because they're using the broader map. This isn't a huge issue since the further away an object is, the less noticeable a low quality shadow will be. If I come down here, it may be difficult to see, but each cascade is blended with the next depending on your position. I'll move forward and back a bit to try to illustrate this. Each of these shadow maps uses a 1024 pixel resolution. Increasing this will of course make the shadows look more crisp, but there will be a performance cost and diminishing returns at a certain point. To get around this limitation, smoothing is used on the shadow edges. Multiple samples are taken from nearby pixels. If I can get close enough. There we go. And also a noise map is used to take a random sample and give it a more natural look. The fragment position will be used to sample from the noise map. That way, as you move the camera around, there won't be a lot of jittery movement. This is also accomplished by moving the shadow map relative to its last location so that no pixels are cut in half with the shadow map. Texture transparency is also taken into account when generating one of these maps. I have an ugly tree here with transparent leaves, and you can see the gaps in the shadow. Over at the castle, we have some more models to check out. Animated models correctly cast shadows based on the current animation frame, as you can see with this ghost. And movable objects will also be updated each frame to cast the correct shadow. Shadows also work with mirrors. As you can see, each object still has a shadow, but it won't be entirely accurate because the cascades are calculated for the viewing camera, whereas the mirror camera will use those same cascades, and you can see some inaccuracies depending on the angle. A Z multiplier is used for the cascade so that further away objects like the castle itself will still be casting shadows even if they can't be seen by the camera. You can see the top of the tower way over there is still casting these sharp shadows regardless of the way the camera is looking. And if I fly down here, you can see it again with the castle walls, that these are nice and crisp even though the castle is so far away. There are plenty of improvements I could make to these shadows, but I am satisfied with the current state. Shadow maps are extremely finicky and a pain to deal with. They require a lot of fine-tuning for each scene, and even a small change can throw everything off. Unlike other parts of the engine, shadows can feel like guesswork, but I am still happy with how they turned out. Thanks for watching, and follow me on Twitter or subscribe on YouTube to see more engine updates and news on my first game.